Hey, hi guys. So in this video, we are going to discuss the parking lot LLD. Let's first go through the feature which we are looking. So the parking lot should have multiple floors where the customers can park their cars. The parking lot should have multiple entry and exit gate. The customer can collect the parking tickets from the entry points and can pay the parking fee at the exit points on their way out. Customer can pay the tickets at the automated exit panel and other many other features just like basics like customer should be able to pay with all the methods like cash or maybe credit cards. Customer should be able to pay the fees even at the exit portal, not just the entry portal. The system should not allow more than the capacity which we have. So if the capacity of the parking lot is 5, then the system should not allow more than 5 cars to be parked at the same instance. Each parking floor, so they can multiple parking floor. Each parking floor can have multiple parking spots. The parking spots can be of different type also, like some can be handicap, motorcycle, compact, large SUVs, and all those things. The parking lot should have the spots for the electric cars also, since they may require the electric panels to charge their vehicles and all that thing. The system should support the parking for the different kind of vehicles, as we have already discussed. Within this car there can be different kind of like sized car, like mid SUVs, big SUVs, and all those things. So that is what we have already discussed. The other one is each parking floor have a display board showing the free parking spot for each type. Basically the system support okay, it's just a fee model, like system should support the per hour model. So that is it. Now let's discuss the basic design which we have for the basic entity. So as we can see through this given feature, so the floor is one of the entity which we have. Customer or user is one of the entity which we have. Vehicles. Vehicle can be vehicle and vehicle size actually. Vehicles are cars or maybe trucks and motorcycles. And even within the car or trucks, they can be multiple size also. So vehicle size or the type cannot be also one of the other entity which we have here. Now another thing is the payment method. It can be cash and credit card. Multiple exit gates basically. A parking lot can have multiple exit or entry gates. That is another entity which we can think about. What could be the other entities is the payment we have already discussed. Okay, I think that is it. So let's see the code which we have already written. Here we have created the enum for the vehicle type. Vehicle type can be car, truck, electric car, van, and the motorbike. Description is just like basic description. This is just an enum which we have. Now we have another function within this enum where we are passing the parking spot types. Now what is parking spot type? We will see the code also. But parking spot type is just the definition of saying what type of spot we are looking for basically. Are we looking for the truck spot? Are we looking for the motorbike? Let's say a car entered into your parking lot. So you will be checking in your Inventina whether the given parking spots which you have, which they can be fitted for what? Are they fit for truck, van, motorbike, and all those things? Now, as we have defined here, it can be handicap, compact, large, motorbike, this, which we were discussing already. The next thing is the account status. Now, what is the account status? It's just the user status, you can say, whether the user is active, blocked, and all that thing. Just a basic user entity. The next one is the parking ticket status. Again, a basic one, whether the ticket is active, paid, lost, or it just like lost the value. Basically, the work is done for that particular ticket. Now, the main entity which we have is this parking lot class. This is here where we are using this singleton pattern. This is also working as an inventory class also for us. For example, if you want to find out whether there is any spot available or not, we can just go to this class and figure it out. That's why we are even using singleton pattern, because having a single source of truth will make sure that we are not double booking any of the spots. So if you see here, the first one is just for the singleton implementation, basically name, address, parking rate. What is the parking rate for that parking lot? The another one is the parking floors. So as we have discussed, we can have multiple parking floors. So we have described it here. Entrance panel. And as we have also discussed that there can be multiple entry and exit panels, so we are defining it here. And the next one is the active tickets basically. Here if you see get instance, this is just a part of the singleton pattern. The next one is get new parking ticket. So here what happens, let's say a car entered into your exit entry gate or whatever, you will pass the vehicle information, then you will try to figure it out whether that we have the enough inventory for that particular car to be fitted in. So what will happen here, we will first check, hey, are we full already, or is there any spot? So we are passing the vehicle type here, then we are checking. This is the implementation which we can do. Here you will just check whether the parking lot is available for the given type or not. If it is not available, you will just not allow it. Else you will create a ticket. You will assign the ticket to that uh, vehicle, and definitely you will install the information, increase the spot count and all those things, just the basic data entries. Now these are the functions which we are already used in the previous function. Now this is the parking spot factory. Now why we need this, because there can be multiple kind of parking spot, and as we have already discussed, handicap, compact, large and whatnot. So for that we are using the factory pattern here. We have defined handicap, sport, factory, compact, large, and here we have defined another. Now this is the parking spot factory. Now we have another kind of thing here, which is a vehicle factory. Now hey, how this parking spot and vehicle factory is different, that we have discussed in our course. It may look same, like hey, in the parking spot factory also we are discussing about the compact, large, and we have another factory called vehicle factory, but they are different. We have discussed more in depth like how they are different. So if you see vehicle factory, here we are this is just a factory for the vehicle type like car, truck, and all that thing. Like why it is needed, all those things we are going to cover in our course. Now the next thing is the observer pattern. Observer pattern is just for we need for the parking display board, like how much handicap spot is visible, is the parking lot full or not. Like it can be display board at the entry of the parking, or it can be an app where they maybe it's getting used, so the customers or the users already know whether they can go to that particular parking lot or not. The next is the command pattern. Now what is the use case of the command pattern? Whenever you are saying process ticket, a process ticket can involve multiple operations. Basically it can be like, hey, whenever we start processing the ticket, we need to make sure that that spot get reserved, the payment also gets completed, we assign a ballot to that particular car, or maybe few more stuffs. Basically that's why we are using the command pattern, to make sure that we are considering it a single transaction. Payment strategy, this is again one of the most commonly used whenever we are dealing with the payments, multiple type of payments. We use the strategy, so we can dynamically change the payment type during the code, during the runtime. So we have defined the payment strategy interface, and then we have implemented the cash payment strategy, credit card, or you can implement more like UPI or maybe some more, whatever you have. This is just an abstract class which we have created, the parking spot. This parking spot we have implemented, if you have seen the previous factory pattern, where we were defining the compact, handicap, and all that thing. So this is a base class for that. Here we are defining the number. Is that parking spot free or not? Vehicle. Why we are talking about the vehicle is, hey, is that this parking spot is for what vehicle particularly? Parking spot type, is it for handicapped or is it for the large or whatever, and all those things. This is the basic function which we have written here. Handicap spot, as we just discussed, just extending that thing. They have already created the factory pattern for this. Now the next one is the main class. The main class is nothing, just a demo class which we are using for showing you how we are going to integrate the entire system. For example, in the interview you will have to run the entire code. So this main function is just showing a piece of work, how what we have done and how it's going to work. For example, what we are doing here is we have created a parking. First we have initialized a service for the parking lot. Then we have a car factory. We are basically creating a vehicle considering that hey, that the car is coming up. The next one is now the same car is trying to get the spot into the parking lot. If it gets work, it gets a ticket. Now we are assigning the parking attendant also to to process that particular ticket, and all these things are done. This is how we are showing that hey, you can show whatever code you have written. So in the interview, you will have to make sure that you are running your code also and the show some output against the given inputs. Now, what are the drawbacks and the issues with this one? So one of the major drawback which we have seen is fee calculation logic. It's very hard coded. It's not enough to accumulate like PCARs. Even there's nothing as such which we are doing. It was mostly hard coded. We have defined that hey, the parking lot for this one is that. So this is one of the thing which we have to really fix it. You need to make sure that the pricing for the given spot and the car can be dynamic based on the events. Like it can be peak hour or some other. Basically, it should be able to change at a dynamic without changing any code at all. Now, the another case is the spot allocation logic is not modular, cannot efficiently handle. So one of the issue with the our given code is the concurrency bug. So let's say if two car came at the different entry gates, they both try to get the same spot. Right now with the given code, the chances are that they may get assigned the same spot. That means duplication, and then there will be definitely an issue if a single spot is assigned to the multiple cars. So this is a problem in our code basically. And another issue is the basically more of a modular issue. We are not able to handle the different vehicle types more efficiently. That is another thing which we are covering, which we will be covering, which we have covered in our course. The next thing is the lack of real time spot availability. So currently, even though we have a display board, but the display board is not properly integrated with the entire real time system. So whenever there is any car, it enters the gate and it gets a ticket. That means a particular spot has been booked, but that update is not reaching to the display. That is something which we need to fix. Again, we are covering this in our course. The next thing is the inconsistent payment and ticket handling. As we have already seen, we do not have any mechanism to check the payment status before exiting. We need to make sure that we are only right now we are just processing the ticket without even checking for the payment status whether it was fine or not. And there may be the chance that the customer might exit without paying if they use the info portal. Basically, there are some bugs in our existing system by which customers can use to exit without even paying anything. No handling of electric. Okay, so yeah, currently we have not added anything for the charging cases. For example, if there is an electric vehicle, they get the spot. If they want to use the charging or they want to charge their car, they currently we have not considered any additional charging fee for those electric cars. There's no discussion and it's not even implemented into the code. So that is also we are covering in our course. Now there are many more concurrency bugs in this code. For example, as we have one is we have already mentioned that if two car try to enter the different entry and they get the same spot, the chances are they will not be the chances are the same spot may get assigned to the system. The chances are that even if a customer is exiting and a customer is entering at the same point of time, the chances are that we may say to the entering customer that hey, there is no spot visible, but there is a spot visible. It just has not reflected to the system yet because of the concurrency issues and all those things. So all these things needs to be handled, which we are going to add, which we have discussed in our codes.